In computer terminology, a honeypot is a trap set to detect, deflect, or, in some manner, counteract attempts at unauthorized use of information systems. Generally, a honeypot consists of a computer, data, or a network site that appears to be part of a network, but is actually isolated and monitored, and which seems to contain information or a resource of value to attackers. This is similar to the police baiting a criminal and then conducting undercover surveillance. Types: honeypots can be classified based on their deployment and based on their level of involvement. Based on deployment, honeypots may be classified as production honeypots, research honeypots. Production honeypots are easy to use, capture only limited information, and are used primarily by companies or corporations. Production honeypots are placed inside the production network with other production servers by an organization to improve their overall state of security. Normally, production honeypots are low-interaction honeypots, which are easier to deploy. They give less information about the attacks or attackers than research honeypots do. Research honeypots are run to gather information about the motives and tactics of the black hat community targeting different networks. These honeypots do not add direct value to a specific organization. Instead, they are used to research the threats that organizations face and to learn how to better protect against those threats. Research honeypots are complex to deploy and maintain, capture extensive information, and are used primarily by research, military, or government organizations. Based on design criteria, honeypots can be classified as pure honeypots, high-interaction honeypots, low-interaction honeypots. Pure honeypots are full-fledged production systems. The activities of the attacker are monitored by using a casual tap that has been installed on the honeypot's link to the network. No other software needs to be installed. Even though a pure honeypot is useful, stealthiness of the defense mechanisms can be ensured by a more controlled mechanism. High-interaction honeypots imitate the activities of the production systems that host a variety of services and, therefore, an attacker may be allowed a lot of services to waste his time. By employing virtual machines, multiple honeypots can be hosted on a single physical machine. Therefore, even if the honeypot is compromised, it can be restored more quickly. In general, high-interaction honeypots provide more security by being difficult to detect, but they are highly expensive to maintain. If virtual machines are not available, one honeypot must be maintained for each physical computer, which can be exorbitantly expensive. Example: HoneyNet. Low-interaction honeypots simulate only the services frequently requested by attackers. Since they consume relatively few resources, multiple virtual machines can easily be hosted on one physical system. The virtual systems have a short response time, and less code is required, reducing the complexity of the virtual system's security. Example: Aurnou. Malware honeypots. Malware honeypots are used to detect malware, by exploiting the known replication and attack vectors of malware. Replication vectors such as USB flash drives can easily be verified for evidence of modifications either through manual means or utilizing special-purpose honeypots that emulate drives. Malware increasingly is used to search for, and steal cryptocurrencies, which provides an opportunities for services such as Bitcoin Vigil to create and monitor honeypots by using small amount of money to provide early warning alerts of malware infection. Spam versions. Spammers abuse vulnerable resources such as open mail relays and open proxies. Some system administrators have created honeypot programs that masquerade as these abusable resources to discover spammer activity. There are several capabilities such honeypots provide to these administrators, and the existence of such fake abusable systems makes abuse more difficult or risky. Honeypots can be a powerful countermeasure to abuse from those who rely on very high volume abuse. These honeypots can reveal the apparent IP address of the abuse and provide bulk spam capture. For open relay honeypots, it is possible to determine the email addresses spammers use as targets for their test messages, which are the tool they use to detect open relays. It is then simple to deceive the spammer, transmit any illicit relay email received addressed to that Dropbox email address. That tells the spammer the honeypot is a genuine abusable open relay. and they often respond by sending large quantities of relay spam to that honeypot, which stops it. The apparent source may be another abused system. Spammers and other abusers may use a chain of abused systems to make detection of the original starting point of the abuse traffic difficult. This in itself is indicative of the power of honeypots as anti-spam tools. In the early days of anti-spam honeypots, spammers, with little concern for hiding their location, felt safe testing for vulnerabilities and sending spam directly from their own systems. Honeypots made the abuse riskier and more difficult. Spam still flows through open relays, but the volume is much smaller than in 2001 to 2002. While most spam originates in the US, spammers hop through open relays across political boundaries to mask their origin. Honeypot operators may use intercepted relay tests to recognize and thwart attempts to relay spam through their honeypots. Thwart may mean accept the relay spam but decline to deliver it. Honeypot operators may discover other details concerning the spam and the spammer by examining the captured spam messages. Open relay honeypots include Jackpot, written in Java by Jack Cleaver. SMTPOTPY, written in Python by Carl A. Kruger. And Spamhole, written in C. The Bubblegum Proxipot is an open-source honeypot. Email trap. An email address that is not used for any other purpose than to receive spam can also be considered a spam honeypot. Compared with the term spam trap, the term honeypot might be more suitable for systems and techniques that are used to detect or counter attacks and probes. With a spam trap, spam arrives at its destination legitimately exactly as non-spam email would arrive. An amalgam of these techniques is Project Honeypot, a distributed, open-source project that uses honeypot pages installed on websites around the world. These honeypot pages disseminate uniquely tagged spam trap email addresses and spammers can then be tracked. The corresponding spam mail is subsequently sent to these spam trap email addresses. Database honeypot. Databases often get attacked by intruders using SQL injection. As such activities are not recognized by basic firewalls, companies often use database firewalls for protection. Some of the available SQL database firewalls provide support honeypot architectures so that the intruder runs against a trap database while the web application remains functional. Detection. Just as honeypots are weapons against spammers, honeypot detection systems are spammer-employed counter-weapons. As detection systems would likely use unique characteristics of specific honeypots to identify them, a great deal of honeypots in use makes the set of unique characteristics larger and more daunting to those seeking to detect and thereby identify them. This is an unusual circumstance in software, a situation in which versionitors can be beneficial. There's also an advantage in having some easy-to-detect honeypots deployed. Fred Cohen, the inventor of the deception toolkit, even argues that every system running his honeypot should have a deception port that adversaries can use to detect the honeypot. Cohen believes that this might deter adversaries. Honeynets. Two or more honeypots on a network form a honeynet. Typically, a honeynet is used for monitoring a larger and or more diverse network in which one honeypot may not be sufficient. Honeynets and honeypots are usually implemented as parts of larger network intrusion detection systems. A honey farm is a centralized collection of honeypots and analysis tools. The concept of the honeynet first began in 1999 when Lance Spitzer, founder of the Honeynet project, published the paper To Build a Honeypot. A honeynet is a network of high-interaction honeypots that simulates a production network and configured such that all activity is monitored, recorded and in a degree, discretely regulated. Metaphor. The metaphor of a bear being attracted to and stealing honey is common in many traditions, including Germanic and Slavic. Bears were at one time called honey-eaters instead of by their true name for fear of attracting the threatening animals. The tradition of bears stealing honey has been passed down through stories and folklore, including the well-known Winnie the Pooh. See also, canary trap, client honeypot, honey token, honey monkey, network telescope, pseudosava, tar pit, trust operation, references and notes. Further reading, Lance Spitzer. Honeypots Tracking Hackers. Addison Wesley. ISBN A0-321-10895-7 External links, Distributed Open Proxy Honeypots Project, WASC, SANS Institute, What is a honeypot? SANS Institute, Fundamental Honeypotting, SIMUD ESMSSIP Honeypot Project, Podcaster Euro Episode Number 2, Honey Monkeys from Security Now. Project Honeypot, the HoneyNet project. Research honeypots are complex to deploy and maintain, capture extensive information, and are used primarily by research, military, or government organizations. Based on design criteria, honeypots can be classified as pure honeypots, high-interaction honeypots, low-interaction honeypots capture only limited information, and are used primarily by companies or corporations. Production honeypots are placed inside the production network with other production servers by an organization to improve their overall state of security. Normally, production honeypots are low-interaction honeypots, which are easier to deploy. They give less information about the attacks or attackers than research honeypots do. Research honeypots are run to gather information about the motives and tactics of the Black Hat community targeting different networks. These honeypots do not add direct value to a specific organization. Instead, they are used to research the threats that organizations face and to learn how to better protect against those threats of value to attackers. This is similar to the police baiting a criminal and then conducting undercover surveillance. Types: honeypots can be classified based on their deployment and based on their level of involvement. Based on deployment, honeypots may be classified as production honeypots, research honeypots. Production honeypots are easy to use. In computer terminology, a honeypot is a trap set to detect, deflect, or, in some manner, counteract attempts at unauthorized use of information systems. Generally, a honeypot consists of a computer, data, or a network site that appears to be part of a network, but is actually isolated and monitored, and which seems to contain information or a resource